graphs.
I actually did everything in 6-point font.
Okay, so
So everybody that's sat in the back because you're afraid I may smell or something, it's okay. You won't see anything. Welcome to the Ninja Developers Talk, where we're covering application security testing here at SDLC. This is not a low-level technology talk. We're going to start talking about some of the tools that exist that pen testers are using, that developers can start using on their own, so we can start embedding this into our development process. Right, we already know that we're going to do our regular development, and then some of the issues that we come across with how we implement our testing into our processes. A little bit about me. My name is James Jardine. I live in Jacksonville, Florida. I'm a senior security consultant for Secure Ideas. It's a small little company based out of Jacksonville, although we do have a couple different locations for some of our members. We all work remote, which is pretty nice. It's the greatest job in the world, right? I came from a development background. I've been a developer for 13 years. And then I started a few years ago, starting to switch over into the application security role. As I noticed, nobody was really kind of taking that on. Every place I went, nobody was doing security. I had a lot of fun with that, since I was the only security guy that would come into our teams. So I remember dropping somebody's tables one time in a test environment because they didn't know anything about SQL injection. He didn't like it, but it was fun for me. That's
why I'm not working there anymore.
He came in one morning, and I went over to him, and I was like, hey, I just want to let you know you have SQL injection on one of your forms. And he's like, oh, okay, I'll go check it out. I was like, all right. I said, but hold on, I got to go reinstate your table because I dropped it. And it was his user's table. And he was like, oh, why'd you have to do that? You could have just told me. I said, I could have. Which kind of goes along with it. It's perfect. I fell into Secure Ideas. Our tagline is professionally evil. And that's what we are, right? We're professionally evil. I'm a SANS instructor and co-author of the Dev 544 Secure Coding in .NET course, which I teach a few times a year. I've created a web config security analyzer, which is out on SourceForge. I just put that up a few weeks ago to make it available to everybody with the source code. It's not built, so you have to download the source code if you want. But basically, the idea is that it's going to go out and analyze a web config file for .NET applications. So that way, developers can do it. Network admins can do whatever you want to do it. You just drop a config file into it, and it'll give you some common areas that we find within security, our web config files for security concerns. Kind of came up with it as I was doing a lot of security code review, which was an interesting position, where we never get to run anything, right? So we had to constantly understand how everything worked, because all we did was get to look at code. So here, we're not going to talk really about code. All right, we're going to start talking about the tools. I participate in 2 blogs. One is my own, which is jardinesoftware.net. Notice the .net, that's the blog side. And I also participate in the Secure Ideas blog for our company, which is just general security. I try to split them up, so defense is the jardinesoftware.net, and it's mostly .net based. So I do a lot of research on .net security. So you'll find that information there. And then if you want to look more attack based, although there's a little bit of attack on mine, I go the Secure Ideas route because we are more attack-based as a company. So basically where we're going in this, right, we'll talk a little bit about the SDLC. We'll do a real quick overview of it in case anybody doesn't know what the software development lifecycle looks like or a secure development lifecycle. So I'll take a quick peek at that. We'll talk about web pen testing methodology and what pen testers are doing to be able to analyze your applications. Because if we understand what they're doing, then we can start doing a little bit of our own. And some of the challenges that we have out there. We'll talk about some active web scanners, some passive web scanners, some proxies that we can use. Anybody use Fiddler or Burp? Right, we've got a couple of these proxies. That's a big part of what we want to do. The web testing frameworks that are available, and then we'll kind of wrap it up. So our development lifecycle, right? We have many different things that constitute what is our development lifecycle. We have agile, right? Waterfall, spiral. There's all these different ways we can do this. And then within an organization, we also have many different ways that we can do it. Some are mature, some are immature. I've worked at many different places, from 2-people shops to multi-thousand people shops. And it's very different depending on where you go. Some have ridiculous deployment policies. Some have, ways that, it takes 3 days to deploy their code, right? We do agile, we do 2-week sprints, 4 sprints. There's going to be a release, and then, it takes a weekend and a half to get it You can also be doing on remote servers. And then you have other places, right, that deploy every day. Yeah, we get a lot of places don't run servers. I don't know why it's hard to deploy. I don't know why nobody's heard of a virtual machine. And just don't get it, right? We have such difficulty there. Right, so there's a lot of stuff going on here when we talk about our development lifecycle. So how do we start integrating in our security into it? So if we take a look sort of at our secure development lifecycle here, right, we have our multiple phases, our training, our requirements, right, our implementation, our verification. We're really going to be focusing more on the implementation area, although we're not talking about code, right? And that's usually where we think about code. We talk about static analyzers. But we're really trying to focus here on what can developers be doing that we don't need a whole lot of input from management. You know, I don't need to go out and get budgetary constraints for, you know, can I bring in Fortify? Can I bring in White Hat? You know, can we get these expensive tools that we can run? We're going to look at open source tools that are available for us that we can implement into our system. And then we see our verification, right, which is where most of our testing is going to be, or it's going to be in production, which is kind of the wrong place. One of the biggest challenges we run into, a lot of times the only thing we're testing is business functionality. Most places that I've worked at, that's what we look at is business functionality. Our QA testers, half the time, don't even have the technical skill set to do anything with the business functionality, right? They have Excel spreadsheets that list out, put this in this screen, click this button, get this output, yep, pass the test. Right? That's not enough for our current state. So that's not going to work, right? We're not testing the security. And it's very simple to get them to start testing, right? We create a simple list to try to get QA, who may not be very technical, to start testing this, right? If you see integers in the query string, mess with them. It's not hard, right? We don't have to be skilled to do that. You know, checking to see if autocomplete is enabled on our password field, our account field, right? Sensitive information. This is stuff that's not difficult for our QA testers to test, but mostly we've been focused on business, yeah, right? And they're in a UAT environment as later on. We can see that we're not doing a real good job, right? We have the open source vulnerability database that's out there, xxs.com, also lists out all the sites that are vulnerable. I know I get in my RSS feed every day, at least a few sites that are getting tagged with cross-site scripting, SQL injection, file inclusion, all these different vulnerabilities that are out there, right? Because we're not testing this. So why, right? It's viewed as difficult. A lot of developers feel as though, oh, security testing is going to be hard. I'm here to tell you security testing is not hard. It is easy. Testers are going to get in. Now test every day, and it's not difficult, right? The things that we're doing as attackers are not hard, and the things that we're using to get into your systems, it's easy to defend against. SQL injection is easy, right? I mean, that's easy to defend against. Cross-site scripting a little bit more difficult, but still not that difficult, right? I mean, we can defend against it. There's just 18 different ways to go at it, but we can defend against that. So it's not difficult, right? We just need to know the tool sets. And some of the reasons why we don't get into these tool sets, right, is we look at it as expensive. Not only is it viewed as difficult, which it's really not, but we also view it as expensive, right? If I'm going to go out and buy Fortify, anybody know how much a Fortify license costs? I don't, because I can't afford to buy it. But I know it's expensive, right? It's way more than I'm going to make in a year. So it can be expensive, right? All these companies are expensive. Some of them may be a little bit more available to us, but we have to be cautious, right? The free tools are not allowed, right? A lot of these tools, we view them and they're like, oh, we can have this. You can't have that application on your machine. We'll talk a little bit about that next in a moment. Tight deadlines, right? Developers are constantly under tight deadlines to try to get everything done in time. Right now we've gone to this agile methodology where you have 2 weeks to implement a completely new architecture in your application. Business doesn't understand it. We've got a lot of stuff we're trying to figure out. So it takes us a little bit of time that we don't have this time to be focusing on security and trying to keep up with security. Right? Typically we perform our testing in production or after it's gone past the development phase. Right? This is too late. We can perform in production, right? But we're scared to test production. Right? We don't want to mess with client data. my boss Kevin Johnson will always say, you know, there's a big run-in with PCI because, you know, I guess they've told him to stop contacting him because he questioned them about, hey, if I siphoned off, you know, 5 million credit card numbers from this company, does that make me, you know, PCI compliant? You know, do I have to follow PCI compliance? Because we're dealing with production, right? I mean, that's real data. I've seen tests, fortunately not ones I've done, where people have siphoned during production tests, you know, a whole database full of social security numbers over an HTTP connection. Right? This is why we've got to be cautious of production. Me, I don't think that's right, because that's not a secure connection. Right? We shouldn't be pulling all those down. You can pull one down and show that you did it. We don't have to pull them all down. And then the thing we found is the earlier we find our vulnerabilities, the less expensive they are going to be to fix. Right? If I can find it while I'm actually coding it, or close to when I'm working on it, it's going to be less expensive. It's going to be less of an impact if I identify that I architected my authentication wrong. Right? It's going to be a lot easier to identify early and fix it early. And I know what the heck I'm working on. Right? As developers, we've all sat there and said, hey, I'll fix that later. I'll put my comments in later. I don't need comments right now. Right? It's the same type of thing. 6 months from now, I don't know what I was doing in that code. Now I have to go back. I lose the time to figure out what I was doing in the code. So now it's costing us a lot more to try to fix these vulnerabilities. But we don't allow hacker tools, right? This is what I was alluding to a little bit earlier, right? Well, what constitutes a hacker tool? And I've seen this in many organizations. Our policies say you can't have hacker tools on your machine. Right? They're dangerous. So what constitutes a hacker tool? I mean, is Burp Suite or Fiddler a hacker tool? I mean, when I do it, it is. My everyday job, yeah, it's a hacker tool. SQL map, definitely a hacker tool. You probably don't need that as a regular developer because that's more exploitation focused. Right? Your Ruby, your Java, all your programming languages. Would you consider those hacking tools? Because you get to use those every day. Right? Visual Studio, Eclipse. I mean, half the hacker tools are written using these items. Right? A lot of them are Python. A lot of them are Ruby. Not that many in C#, just because, you know, it's Microsoft. Nobody wants to hack Microsoft. That's not cool. Okay? One that doesn't run on Linux. And it's just not as cool. They're doing the C# writing hacking tools. But Fiddler's written in C#. So if we consider that a hack tool, even though it's called a debugging proxy, we can do that. Right? But how many places are listing and say you can't have it? So I worked at a place, their policy stated you can't have hacker tools. But nothing defines the list of hacker tools. Now, does it make sense that the guy on the 3rd floor that's doing customer service or receiving telephone calls has Cain enable on his machine? No. Which also leads to walking out the door. That doesn't make sense, right? I mean, those type of people don't need Cain enable, nor do developers need Cain enable by that. Right? But there are situations where we do need some of these tools. And if we're using them in the proper manner, then it's not really an issue, right? So we can create exceptions to our policies, right? We have to enforce them, but that's the whole thing with policy, right? We have to make some way to enforce it. Can we go and say, yes, we're going to allow developers to run X, Y, and Z tools, but here are the parameters for which they can run them. So yes, you can run Fiddler, because it says debugging, so we'll go ahead and say it's not an attack tool, even though it works really well. We'll let you run Fiddler, but you have to only run it against your machine, right? Or you have to run it in a virtual machine that has local-only access, right? It doesn't connect to the rest of the network, it's local. And any of these tools that we're going to talk about, we can do that with, right? We can limit them to local only, because the concern from the company is, A, either you're going to hack our own websites, which seems silly since you wrote them, so I don't really need to spend a lot of time hacking them if I'm a developer of them. I know the encryption keys and everything else we do wrong by putting it in the source code, hard-coded. Or you're going to start hacking other companies, and it's going to look like it's coming from us, right? So now the company's going to get a bad reputation because now you're doing something mischievous from their locations. So the big question is, do you trust your developers? I mean, do you trust them enough that you can say, yes, I'm going to go ahead and allow you to use these tools so you can test our applications to protect our data? If you answer no to that, then you need to fire your developers, right? Because if you don't trust your developers, they're the wrong people you want writing your applications. And if I have access to Visual Studio or Eclipse or whatever language be your flavor, then I can write any of the tools that we're going to talk about, because they're all written in these languages. And if your developers aren't good enough to write tools like this, then, well, again, maybe you can fire your developers. Maybe they're not. But this is what we need to think about. We're using these same exact tools. We can write them all. Now, if we actually do let them use the tools that are out there, at least with the fingerprint then, we know what they are. We can identify them on their system. If you force them to go out and write their own, then you have no idea what's out there. So if me, Joe, developer, decided I'm going to write Fiddler on my own, there's no way for the company to track that. We want the trust coming back and forth between the developers and the company to say, hey, we trust you with this. Go ahead, you can use these tools.
Question. Under the open source tools you talked about, have you run into any problems with the way the licensing agreement works so that it cause downstream problems? Like, already the license, if you use this tool to scan your software, you have to make your resulting software open source. Or anything like that.
I haven't seen anything that requires anything like that. But you do have to read the terms, right? I mean, you have to understand what you're doing with the tools and make sure that it's not. I wouldn't see where scanning it would require making the source available, but you know, if you're actually using code inside of it, you know, hey, I'm going to take this chunk of code and put it in my app. That's where you run more into that type of thing. Then I scanned your app with this, and here's what we get. So some other challenges that we face as developers, right? Training. We don't know what we don't know, and security is a big of what we don't know. And that's just because that's the way it's been. I know when I first started developing, I was going through a class. We were doing Visual Basic 6, WinForms, and we had a stupid little form we were creating, and it had an age field. And I remember because it was an int value. And, you know, put my form together, instructor comes over, and I'm like, yeah, it's done. He comes over and puts his name in the age field. What? Of course it blew up. It says age. I don't understand. Right? That's how developers think. It says age. Why are you putting something else in there? It says your name. Why are you putting syntax in there? So this is kind of a problem, right? That's the way we've been thinking, and we're trying to change that mindset. In addition, developers are focused on the current changing technologies. We have time to focus on security. Look at all the changes. .NET 4.5 just came out. I mean, we're riddling through new versions of stuff. Now we got to learn all this new stuff that's available in my version. And I apologize if I talk about .NET too much. I was a .NET developer. So most of my references will be there. But right, I mean, all these frameworks come out. They have updates all the time. So we have to keep up with all these updates and all the new technologies. Oh, we got to do jQuery. We got to do this. Everybody's doing that, which is great for us because most of those are excellent for penetration testers. But right, devs want to have all this cool stuff. The business wants to have all this cool stuff. So we're trying to include all this stuff in there. Developer cons, they don't focus on security. Right? Go to TechEd, go to Java 1, go to most of these. There's not a lot of security talks. Right? We're talking about all the new great technologies coming out, HTML5 and all this good stuff. But we're not really talking about security. The problem is, developers don't attend security cons. I was at DerbyCon this last weekend. How many people were developers at that con? I can't imagine probably too many. Right? Developers don't hang out with the security. There are two segregated groups. And we don't talk to each other. Sure, us on the security side, we put down the developers. You guys suck. You know, developers are making the rule wrong. And you're going to crash the whole system. That's actually Facebook. But, right, I mean, we just throw them under the bus all the time. Oh, you guys are horrible. You guys are horrible. You know, sit in class. Hey, I'm going to pick on the developers because you guys are the ones doing everything wrong. You know, and it's the world against them. As a developer, even if you have a 5-person team, 10-person team, that's 10 minds trying to build the software properly, and you have the rest of the world trying to attack your system. I want to find flaws. How many researchers are out there now, right? That's all they do is these bug bounties and trying to poke holes in systems, right? And they have nothing better to do with their time but do that. So it's difficult. And trying to get that training in. So, talk a little bit about the web testing methodology. There's 4 steps that we go through as we start doing our pen tests, right? These are cyclical, right? So we're going to run through them. They feed off of each other. Sorry if the blue is a little hard to read, but it's recon up here. It's recon, mapping, discovery, and exploitation. Right? We'll talk about each one individually, but as we start going through a test, we're going to go through these different steps. Now, as a developer, we may do these a little bit differently. Exploitation may not be top of our priority. Right? Do I need to go in and see how far I can exploit as a developer testing my own system, when all I really need to know is I have SQL injection on this area I need to fix. Recon, same kind of similar thing as we start talking about those. But as we start cycling down through these steps, we're going to have more issues that start arising. So our first step, right, our reconnaissance. Our successful attackers are going to focus here. Every test we do, we start off doing reconnaissance. Right? We want to find out about your system. We want to find out about your company. Any information we can find. From a developer's point of view, I want to find if you're posting code out to the internet. Are you looking at forums? Are you looking, at Experts Exchange or any of these type of sites where you're saying, hey, I can't figure out how to do this thing, and here's my code. That's always great for us, right? Because if we can find some source code by you, then we know a little bit about how your system works. If we can start identifying, that you're using cryptographic functions from online, what are the chances you didn't change the hard-coded key in that function, right? Everybody that uses Rindell encryption, if you look at their code, uses the same exact code snippet. You just pray that they actually change the bytes for their cryptographic key. Because most of them probably don't, they just throw it in, right? Because we don't think about security that way. So that's something we're looking for. So, make sure we have architectural diagrams. What can we find? We do tests, but we go out and start doing recon. We find architectural diagrams of the network. We find information regarding the password reset. We find information about the default username and password for the systems. We were doing a test not so long ago. Every interface I came across, the first thing I did was go out and look and find out what the default username and password was. And 90% of the time it worked, which was not good. So we're looking for this type of stuff, because as developers we don't think about, somebody's just going to go out and look at this. Finding help documentation about the application, how does it work? How often do you see websites that don't actually put any authentication around their health documentation? I've seen this many times. Right? Their whole health documentation is available publicly, but you have to log in to do anything in the system. Well, for us, that's good, because if I can see how your system works before I even get into it, and how your business logic flows, then that's going to help me as an attacker get in. Again, developers, we probably know most of this stuff. We may not know where source code is if team members are requesting help online. But for the rest of it, a lot of this stuff we're kind of aware of, right? So recon's not going to be really big from a developer standpoint, but it is still something we want to think about as we're going through this process. Then we move on to mapping, right? How does the application work? What functionality is available to us? Is there user management for returning visitors? What's available in our application? And as we start looking at this from a developer standpoint, we think of it in smaller chunks, right? From a pen test, the application should be pretty much done. So there's a lot of information we're looking for. We break this down into a developer standpoint and say, hey, I'm working on this functionality, right? Because we don't want to do this on huge releases. We want to do this on everything we're doing, right? Building in the peer review, building in all this stuff that we're going to think about. So we might not be looking at the application as a whole. We may be just looking at a small piece of it. Maybe we just added a shoulder card, and that's the piece we're focusing on. So the tools that we're going to look at, we can do that and start to build this into a process. Our discovery, right? We have to start figuring out, okay, here's where our vulnerabilities are. This is more of like the vulnerability assessment side. We're not going to exploit it. We just want to identify that, yes, we have an issue here, right? This is where we really want to focus. Here's where we're going to have cross-site scripting, whatever. Some may require exploitation, directory traversal, that type of stuff will require us to actually exploit it during the discovery phase, because that's just the way it is. The thing to keep in mind, though, right? Discovery is made easier because we have source code access. We are the developers, so we can see what's going on. If we're doing code reviews, then hopefully we're identifying where the key points are. This is a lot of things people don't do. There's not a lot of secure code review. People do peer reviews, but it's not focused on a security matter. So we miss a lot of stuff. So trying to get people involved with that. So hopefully as we start identifying tools that can do these checks that the attackers are doing, they can start then pulling that in and understanding more about how to do these different type of checks. And good code review. And then finally is our exploitation, right? How far can we go with this vulnerability. This is one of the fun things as being a pen tester is, how far can I take this? Okay, I found SQL injection, but what does that really mean? Right? And that's one of the things that management, a lot of places have a lot of difficulty with, is what does it mean if I tell you have SQL injection? Right? Can I get into your database? Can I get all the way into your system and create users and accounts? We've done a lot of stuff with SQL injection, right, where you add users to the network. I've pulled down databases, entire databases. I actually got blocked from a major hosting company, which actually sucked a lot because there was a lot of sites I couldn't go to for like a month while I was waiting for them to block me because I was running SQL map and pulled down all these databases for a client. And then I was blocked from a lot of sites. The unfortunate part was they blocked me after I pulled everything down. So I kind of won on that front. I had everything I needed. I just couldn't then surf the sites anymore. I had to start routing through somebody else's proxy for a while to finish our test. But how far can we go with that, right? SQL injection is pretty serious because we can dig our way in to the network cross-site scripting. Where are we going with cross-site scripting? There's a lot of stuff we can do with cross-site scripting, but if you ever see a pen test report, what do you see on it? Alert box? Right? We pop a message box, which isn't really scary. Oh, you popped a message box on me. Right? But when we start bringing in beef controllers and some of this other stuff where we can show installing malware on the system just by going to the website, now we start understanding what's the true risk to our system. And some of the things we have to do as developers is show proof of concept of that. Because if we find cross-site scripting and we say, hey, we really need to take care of this, and management, we don't have the time to go back and fix that. If we show a proof of concept that fully take control of the machine, they start to realize, oh wait, yeah, we really do need to start looking at this. So that's where the fun and the exploitation phase comes from. Again, I don't see developers really doing exploitation. One, they're probably only exploiting their own local boxes, hopefully. Cross our fingers. Because policy states that, right? We can only attack our own local machine because we don't want you attacking production. So some active web scanners that we have. W3AF, the Web Application Attack and Audit Framework. This is a nice little tool. It'll do spidering for you. It'll do scanning. It'll even do exploitation. It ties in with SQL Map and some other tools to really get us out there for us. It's got a nice UI. It's nice, but it's got a UI. And it also runs from the console. So we have a couple different options on how to run it. It's going to be easy for developers to get in and start working with it, right? And that's the key that we want to put across here, is for developers to start integrating this in. We want simple steps, right? Baby steps coming in. So let's think about some tools that we can just easily implement that when we talk about later, the frameworks, right, they come bundled nicely for us that we can use. So there's a lot of stuff that's going to target for us. The GUI is simpler. Maybe not for other development types, but Microsoft developers, right? Nobody likes command line in the Microsoft world. Can't even believe CMD actually exists in Windows. Nobody likes command line. But we like the GUI. So here's an example of what the GUI looks like. So we can see our profiles over here, and then we can select what type of scan that we want to do. So it's all point and click in here. So we have different plugins that are available. The nice thing is it's extensible, right? People can add new plugins to it if they want. We can find new plugins available for us. We have our output configuration. What type of response do you want from this? Do you want a report? Do you want just a display? But every app starts with the target URL, which is up here. All right, so it just does one URL. Enter in the URL, fire it off, and just let it scan. Right, so we can just let it go. We can do other stuff while it's doing this. Right, it's not taking our time. It just took time to start the scan, and then we can let it go. You can do entire categories over here for our plugins, or you can actually limit down and say, hey, I only want to do these 5 things within this category. Some of these things will start going out to Google and looking up email addresses and trying to find all the information they can find about it. Right, there's going to be stuff that's a little bit more than what we're looking for. So we have the ability to limit that down a little bit. To run it, real simple, right? We enter the URL, we select our plugins that we want to run, and then we press start. Not difficult, 3-step process, pretty easy. And then we look at the results. Our potential vulnerabilities are listed, right? I mean, everything's always potential. We don't necessarily have a guarantee that everything is a vulnerability. But it lists out what it thinks is going to be an issue. Now, some of these things you might find not really that big. If you're in a dev environment and you're actually using a self-signed cert or something, that type of stuff, you're going to just kind of throw off the side because it's going to hit you up about that. We can look at all the responses, the requests that are sent. So if you do see a vulnerability here, we're talking the server header, right? Then it's actually going to show you the request that went up, the response that came down, give you some description about what the problem really is. So it's not that we're just identifying, hey, you have cross-site scripting, but it's also going to give some information for the developer so they can start understanding how these vulnerabilities work. Like I said before, we can also script it because it has the console piece. So if you don't want to have to go into the GUI, if we want to start embedding this into our normal development process, then we can start scripting out what we want to run. So that way, if we either put it out on a build server or something like that, we can have it run nightly against our app if we're building that often, or on a set schedule. Right? Every few weeks, we're going to kick off a W3AF scan and make sure everything's okay with this. Of course, the system actually has to run. Right? This is a stack analysis. Everything has to be functional. But we can kick that off, and we can do custom scans. Right? So we can kick off each one, scan it. And this is the same stuff that you're going to get. A lot of pen testers use tools like these to run this. So why not have us run them before they run them to keep it going? That way we know what they're coming out with. I've seen places where we run Fortify and developers will run Fortify, but they use different settings. Right? That's always an issue. Right? If you go in and you implement W3AF and you're like, oh, okay, I'm going to set these settings, and you run it, and then you have a pen tester come in external and they run something different, then it's a little, you're going to get different results. And you may get some kickback from developers saying, but wait a minute, when we ran it, we didn't get that. Right? So find out if you do have external, what type of settings do they recommend using, and just play with it a little bit. And we'll talk about targets we can use to test out these apps and learn how to use them. Skipfish, which is another application, it's GUI. It's command line only. There's no GUI for it. Unfortunately, the big thing about Skipfish is it's fast. Right? It's probably the fastest scanner out there, so it's really efficient. Right? It's written in C. Its claim to fame is that it's fast. They don't have as many false positives, right? So they have some analysis in there that's trying to rule out all the false positives and give you real results. And there's a lot of things that it's going to look for. We can put it on Windows. It's supposedly supported on Windows if you have Cygwin running, but mostly you're going to find it out on Linux distributions of some sort. Types of findings that we're going to see out of Skipfish, right? Our SQL injection, our XML, our XPath injections, cross-site scripting, stored, reflected, password forms using non-SSL. I mean, this is just a light list. You can go out and look at their full documentation, and it'll list out all the different things that it's trying to identify. So these are all good things that we want to identify. Again, it's automated, so you kick it off, and there it goes. Downside is you want to make sure you kick off against your local machine because it's really heavy on traffic, right? It sends a lot of requests. I think one thing showed 2,000 requests per second that it can send out. So we don't want this obviously going out on a corporate network. Hey, let's hit our dev server with this thing. But there's no reason why developers can't use this locally, run it in some sort of machine, local host or virtual machine that just hits their computer and runs it. Right? So now we'll have all the network traffic, and I think even in that setup you might even see 5,000 or 6,000 requests a second that it can send out to you. So hopefully it doesn't crash your machine. To run it, we have a large number of options. Again, it is command line. The big thing is we're picking what type of dictionary you want to use if we're doing brute forcing type of attacks. Again, it is a large number of scans, so if your server's not that strong, right, a lot of times our dev servers might not be very up to par. We have to be a little bit cautious of that. Make sure we have enough memory, right, because if our log files get too big, we can run out of memory on that. The nice thing about it is, too, that it doesn't matter what the site is in, right? So if some portions of the site is PHP, some portions of the site is .NET, Skipfish can handle this. It actually learns as it's going. It is okay switching between languages on the site, which a lot of them don't mention support of trying to do There's a couple dictionary modes that it uses. These really put a big difference on how fast it's going to run. So we can do no dictionary if we want. If we want to add in a minimal brute force, or we're actually trying to brute force path names, file extensions. Depending on what level we want to do that at, depends on how many requests are going to go out. Right? So how fast is it going to run? How heavy is it going to be on the network? To try to identify all these items that are out here. For the reports, it gives us a nice HTML report, which lists out its idea of the findings, what the ratings are. You can click on them and actually see the request and the response that came back. Skipfish runs a real minimal request. So if you have to add in extra headers, if you need the user agent, if you need something like that, you can actually specify on the command line how to put all that in. So once you get it up and running, and once you start getting your scans set up, it's not too difficult to just kick off. Hey, I want to kick this off. I want to kick off W3F. And this time, right, we can space these out and run different tools. And they're all going to find different things. They all work a different way. So some might find cross-site scripting better. Some might find SQL injection better. It's all about managing and determining which is going to be the best tool for our environment. For our passive web scanner, Rat Proxy, which is a really nice proxy tool out there, right? We're just going to set it up, let it run, and in the background, and then we're going to send all our traffic through it. And the nice thing for developers, and even QA, right? We talked about QA. We don't do security testing, right? Most QAs do business logic testing. Well, the premise behind Rat Proxy is that it wants you to pass in just your normal default input. It doesn't want you to hack it. It just wants you to use the site normally. And it is going to look at the results and try to make a determination of whether there's issues there. Right? So that works out perfect for developers doing testing, right? If I'm just firing up, hey, I just did this little piece, I need to test it out in the browser, well, run Rat Proxy behind it. And test your piece. Test it like you normally would. And see if Rat Proxy lists anything out that you need to be aware of. We can chain it with different tools. So we can run through other proxies, right? But be careful if we're running through other proxies so we don't want to manipulate the data before it gets into Rat Proxy because it wants the clean data. It does run on Linux, Mac, and Windows. Windows requires Siglin. We have a post out on the Secure Ideas blog that actually goes through installing Siglin and Rat Proxy onto a Windows machine if you're interested. And it also decomposes flash objects, which is pretty good. To run it, it's all command line, so we just go in, we specify what type of scanning we're doing. It's mostly passive scanning, but we can target active scanning if we want to. But passive is usually going to be good enough for us. Right? Just go in, specify, hey, I just want to fire up the proxy like we're doing any other proxy. Tell it what log directory we want to use so it can log our file out. And then we set our browser to use it. Use the application normally. Don't mess around, it confuses Rat Proxy. Use it normally, and then when you're done, you spit out a report, which is just another simple command line to actually convert the log file into an HTML report. So you can see it lists out all the vulnerabilities that it's identified, ranking them based on risk levels that it's putting on. Right? That's the difficult thing. It's hard for us to put risk levels on vulnerabilities, right? Because it all depends on what type of system you're on, what's your business. One risk for one person is different than a risk for another person. So just because it comes out as critical doesn't necessarily mean that it's truly a critical risk. So just keep that in mind. But it does show us a nice report of all the stuff that came out. So talk about some proxies that are out there. I love proxies. Burp is my favorite. I use Burp all the time. Most pen testers will tell you they use Burp. I don't know too many that don't use Burp. It does come, it's both free and there's a commercial version. So you can get the free version that has a lot of the functionality. The commercial version adds in the scanner search functionality. It takes away the limiting, the throttling that they put on some of the features like Intruder, Spider. Some of these things get throttled down a little bit if you use the free version. But it's not expensive. Right, it's like $300, $400 for a license for Burp, which is well worth it. This is pretty much the only proxy I really use unless I use Fiddler for .NET stuff. It is available on multiple platforms. It's written in Java, so you can put it on anything. We'll see when we talk about frameworks where it comes available pre-installed. Of course, a lot of frameworks install it for you. But it's got a proxy. It's got a spider to go out and crawl your website. It's got scanners, both active and passive. Repeater, decoder, there's other stuff too. I just didn't want to list everything on there. Here's a simple look at the GUI for it. I actually ran a scan against a vulnerable system just to get some information on here to see. But we have our sitemap over here, which lists all the pages it's identifying. Right, you're going to spend a lot of time looking at that. This is a great way to find out, is your application calling out to some other site that you're not even aware of? You know, maybe you're not even realizing that you have references out to, you know, external third-party sites because you're using either JavaScript from them or, you know, calling out to ad systems. Right, we found ad systems this way that, hey, they're calling out to ads. I found camera systems because there have been links out to cameras, straight out to IP addresses for cameras to get into. So there's a lot of stuff we can see using that site. A history of what we've been doing, and then our request response. And then we always have a filter up here. They kind of hide it from you, right? So if the first time you go into Burp, you don't know this is a filter here. But if you actually click on this bar, it'll drop down a filter so you can specify what you want to see, what you don't want to see. You can add items to scope. There's really, I mean, there's a lot you can do with this. That's why most pen testers use this, because there's just so much we can do. The repeater control, this is one of the cool controls that we have on here. Right. So as I'm surfing through a site, I find something interesting. Maybe it's a login form, maybe it's someplace that it might be cross-site scripting or SQL injection. I send it out to a repeater, and then I can just sit here and keep manipulating the request, execute it, and watch the response come down. So I don't have to keep going through my browser to keep resending these out, right? Because that's too much work. I can just do it straight from here. And then I can analyze the output. There's also a comparer where you can take multiple outputs or multiple requests and compare them, which is really good if you're thinking about error messages coming off a login screen. I actually was trying to find out on a site why one screen was highlighting a certain tab on the form and another one wasn't. And I was actually using compare to compare the two responses to see what's different between here. Right? Attackers are going to use that. I mean, we'll use things as much as time. I've been on sites or tests before where I look at the time that the response come back, where we can actually determine username harvesting based on the SQL response time. So we can use Repeater to go in and start looking at these and then comparing links coming out, all that. Saves your history, analyze your response. Intruder's really nice, kind of complex, right? This is the attack tool, right? Intruder's just your automated attack tool. There's a couple different attack types we can do. Sniper, right? Basically what we have is we have a tokenized system over here. So here's my request, and here are my parameters that I'm going to target with my intruder attack. So Sniper says, hey, I'm going to take a list of payloads, and I'm just going to start throwing them into each one of these spots until I run them through all of them, right? So there's only one payload set. Battering ram, still one payload set, but I'm going to take each payload and put it in every token for the request. So if I want the same thing in every field, just throw them all in, let it run it, and then I'll run the next payload, throw them all in, let it run it. Pitchfork, if we have two payloads, we get more than two payloads, but multiple payloads, right? So think of two different lists, like username and passwords, for example. And this username is going to go with this meta, or username and company. I know I have a company ID of this for this user, company ID for this user, and I'm going to put those in the two tokens. So payload 1, payload 2, items 1 first, then we'll go to the second, then we'll go to the third. Right? So we start attacking that way. And then finally, we have the cluster bomb, which is the big daddy of it, which is going to just run every permutation of all the payloads in there. So it'll run payload 1 through this one, and then run through all of payload 2 with payload 1, right? Just brute forcing through. Good thing to think about it is, hey, I'm going to brute force to see if anybody's using the top 3 passwords of all time. So I take a whole list of usernames, stick it in the username field, and then I have a whole list of, just a small list of the top 3, because I don't want to lock everybody out. I made that mistake. We don't want to lock everybody out. Fortunately, it wasn't with Intruder, it was Brutus, and it wasn't a website, it was actually the network. But keep track of how many attempts you have before you lock the account out. I actually locked the CEO, pretty much everybody out of their systems. Go so there's a lot we can do there. The scanner, right, it's got passive scanning, so and this is part of the commercial version, but as you're sitting here browsing through the site, it's looking at stuff, identifying flaws that are out there.
Could they use that as a brute force attack type of denial of service?
Oh yeah, yeah. Yeah, Intruder's great. I mean, you could denial of service somebody with it. There's other ways that are probably easier to denial of service, but because at some point Java's going to run out of memory, and you just denial of service yourself. But there's probably better ways to do it denial of service, but you could do that. Yeah. But I'll use it to test to see if there's actually lockout functionality in the site, because a lot of places, you're like, oh, I'm going to put in 3, 4, 5 bad passwords. I'll just throw 100 in and just let it go and see if I'm locked out. Actually, I ran 3,000 against somebody. They never locked me out. That was a problem. So the scanner, right, it's commercial only. Does our passive scanning. Can do active scanning as well. We can limit the scanning to just what's in scope, so you don't hit production systems or external systems that we're not supposed to be playing with. Another tool is the OWASP Zed Attack Proxy, which is pretty actively maintained now. They kind of dropped Web Scarab and made this their tool of choice. Another good one, it's got a nice GUI. Again, we have a lot of the same type of tools that we're seeing in Burp. Here's what the GUI looks like for the Zed Attack Proxy. Right, so we have our sites panel, so as you start scanning or surfing the site, this will start populating for you. You can run brute force attempts, active scans, and it starts popping up and identifying SQL injection, cross-site scripting, all this stuff, right? And again, all we have to do is surf through it, and it's going to start finding this stuff for us. Not a lot of effort on the developer side. It also has reporting. A lot of these do HTML reports. This one actually does XML reports. You can export URLs to a file. You can export sessions. There's responses, messages. There's a lot more we can do with this. So spending a little bit of time with it. I actually ran this against the Samurai DVD, one of the vulnerable apps today, and it works out good, right? And there's ways we can test this. Fiddler, I don't really use that proxy, by the way. Not that I don't like it, but Fiddler and Burp do what I need. Fiddler's free. It was created as written in .NET. And it's a debugging proxy, right? I mean, it says on it this is a debugging proxy. Nobody's really looking at it as attack. It has timeline, inspector, composer. I mean, it's built a little bit more for trying to debug your requests going back and forth. But it can be used as attack if we want to. It's extensible using JavaScript. You can write .NET DLLs if you want to extend it out. We'll look at one of those extensions. Available for Windows, not really available on anything else, unless you try to port it over. One of the cool extensions they have, which is sort of like the scanner we've been talking about in Burp and Zap. These type of scanners that are out there, is called the Watcher plugin. It's a passive scanner, and just as you're surfing, it'll start looking through and identifying things that it finds. So if it sees cross-site scripting, if it sees that the cookie doesn't have the HTTP only flag set, it's going to start finding these things and it'll start listing them out. And if you think these things aren't going to show up in a pen test report, they are. Right? We cite all the time, HTTP only not being set, secure not being set. So if we're running these things and catching them while we're developing and just testing our little pieces, then we're going to be that much faster at fixing the problem. Say, oh, I need HTTP only. Or if we need to have access to JavaScript, at least we can document and say, oh, no, I don't need to set HTTP only because I need this for something. Right, but we need a reason. If your session cookie is an HTTP only, you need a reason. I don't think there's any that are really good. But we need some sort of reason for that. So web testing frameworks, right? Where do we get all these tools? So the idea is let's put together, and Kevin Johnson and Justin Searle put this together. It's called the Samurai WTF. And we swear WTF is web test framework. So what it is, sure, that's what it is. Right, so the idea is it's a live DVD, sort of similar to Backtrack. If anybody's heard of Backtrack, OWASP has a live CD. And it's got all these tools all built into it. We use Samurai a lot on our pen tests because everything is built in, right? All these attack tools, Burp's built in. W3AF is there. It's actually one of the official distribution points for W3AF. Skipfish is there. The Zed Attack Proxy is there. Pretty much everything except for Fiddler. If it's not Windows-based, it's probably there. And there's a ton of other tools, right? And all the tools that are in the 542 framework, or the SANS 542 class, which is the pen testing course. All those tools are there, so you can see a list of some of them: SQL Map, SQL Ninja. Now, I'm not saying, when we talk about what's a hacker tool, yeah, SQL Map's a hacker tool, right? I mean, there's really no reason for us to see, but we could get use out of it. Comes with a pre-configured wiki, so if you guys are working on something together, probably not as much big deal for pen testers. The nice thing about having this all set up for us, though, is as developers, we can go out and say, hey, look, I just want to have a VM where I can run this local only against my machine, and then I can start testing my sites, right? I don't have to go in and install every little bit onto my development machine. Or we could install this out on a special server that only certain people have access to. Say, look, here's the tools. We can use them to test our sites. We're not going to give access to anybody else, right? We want to limit it down, and here's how we modify it, right? So we can audit it, right? We know who's logging into the box. We know who's doing stuff with these tools. Some targets, right? So if developers want to learn how to practice this, I've had developers say, they've come into me, oh yeah, I did, I was out last night trying SQL injection on this site. I was like, what? No, I said we could try SQL injection on other sites. Right, so if you're looking to try to get into this, Samurai comes with multiple targets on it. DVWA, which is the Vulnerable Web Application, Matilde, Dojo Basic, Dojo Scavenger, WebGov. These are all vulnerable applications that you can just go run these tools. So you can take W3AF and point it at any one of those applications and start practicing how to use them. Skipfish, same thing. Any of these apps. So please, if anybody actually wants to go try this out, don't do it on public sites or private sites unless you own it or have written confirmation that you can do it. Use something that's built in. And again, there's other live CDs. OWASP has one that has WebGo, I think, pre-installed that have this, right? So we can have this capability to test without breaking the law and going to jail. Because I don't think we want to do that. So just to wrap up, right, I mean, our security testing is critical to our organization. And as developers, we need to start getting better at getting it in and taking control of what we have access to. I have access to my own machine. If I can get in where I can test locally, then let's do that. It is easier than we expect, right? I mean, these tools are easy to use. It may take a little bit to get them set up if they don't use the framework, right? Skipfish, I know the first time I did it took a little while. But once you get it set up, or if you use Samurai or some other built framework, then it's all there for us. Right? So real easy to go in, we can run the command lines, and once you get them, copy and paste them. Because that's what developers do, copy and paste experts, right? I don't write code, I copy code. And hopefully I understand what it looks like. And try to get this built in before we get into production, right? Because production, as we talked about, is going to be too late. So that is it. Are there any questions? Yes.
I have two.
We only get one.
When you said about having basically the help page without a password, a lot of things that I run into, this is the second part of the question, is the management says that's on the LAN environment, don't worry about that. So you shouldn't have to worry. Like there are web applications that are really incredible internally, but all it takes is somebody to get into the internal network.
Right.
Is there any good counter to that? Or is that a valid?
Yeah, I mean, it's really more towards public facing, right? If we have a website on, whatever.com, because you have the competitors, stuff like that. I mean, if they get into our network, it's a bigger problem than finding our own documentation. But we still want it to be protected. I mean, if I break into your network and I find help documentation, it's going to help me big time, right? Because now I can access it and I know what's going on. Especially if that documentation has username and passwords in it.
I think the financial software,
yeah,
HIPAA related, you might even though it's behind your firewall.
Right. Well, it depends on what that help information has.
Yeah.
Right. I mean, if it doesn't have anything that's necessarily secret, right? I mean, but a lot of I've seen financial institutions that, they have screenshots, walk through how to use their application. If I get in, at least I already know how your app works. And B, if I feel like competing with you, I'm just going to write everything that you just put in your help documentation and reproduce it. Right. But yeah, it's less of a worry if it's internal. But you may see that on the internal tests. But again, it boils down to the risk of, is the company willing to take the risk of internal, there's nothing really in there. It's more geared towards that type of thing. Yeah. If I go out to Google.com and find their internal. Oh, yeah, of course it is.
So you mentioned having this testing like the Samurai framework in a local environment so that it can only point to a website that you may also have maybe on a virtual box. Would the idea be that it can't see out to the internet at all, or even to other local institutions?
Yeah, I mean, it's possible, if I load that up in a VM, like oftentimes we run in VMs, right? So if I'm doing a test, I have tons of VMs running. But the idea is you can run a local-only VM that can only see your local box. So in that case, I could set it up and say, okay, I'm a developer. I can go ahead and fire up a VM, point it at my internal, it's going to be on the 192.168 VM range.
But I'm saying not even on the network.
Yeah, it wouldn't appear at all on the network.
Because, thinking that if I wanted to penetrate a large number of networks, it would prevent me from writing a plugin for one of these penetrating testers and just distributing it, and then,
and that's a concern.
Myself, right? How do I know what I'm downloading?
Right.
The opposite.
And that is a concern, right? I mean, we don't know. I mean, they're open source. We can go and look at the code, right? But we don't know if an update's been done that, could be malicious. I mean, I always like the idea of being able to run it local, where it's not going out to the internet, it's not going out to the rest of the network, it's going to my machine only, and I can target it as my dev.
On the active scans, right, so they're actually running some code to some extent on that local machine. And most people who might have some jQuery sources at like external sites, Google or whatever, it wouldn't be a real comprehensive test then if you're using resources from public-facing sites to supplement your own. Your own site.
Yeah, and I would usually recommend turning those off. Like the W3AF, where it's like going out to Google to try to do stuff. I wouldn't select those plugins. Or if it's internal only, it won't be able to make it out anyway, right? Should I go and shut this down? Yeah.